Let's graph this linear inequality in two variables. Y is greater than negative 4x. So we start with the related equation, y equals negative 4x, and we find the boundary line by graphing this equation. So let's find some ordered pair solutions of this equation. For example, if x is 0, y is negative 4 times 0, or y is 0. Let's go ahead and pick a few more values for x since this equation is solved for y. In other words, if x is 1, y is negative 4 times, remember x is 1, so y is negative 4 times 1, or negative 4. And what if x is, say, negative 1 itself? If x is negative 1, y is equal to negative 4 times negative 1, or positive 4. Now let's plot these three ordered pair solutions. 0, 0, 1, negative 4. That's 1 to the right, and 1, 2, 3, 4 down. And then negative 1, 4, that's 1 to the left, 4 up. 1 to the left, 1, 2, 3, 4 up. Notice these 3 points all lie along the same line. Here is now when we need to go back to the inequality. Because it's strictly greater than, then we actually draw a dashed line. For strictly greater than and strictly less than, draw in or sketch in a dashed line. Let me go from the bottom here. There we go. Because points along this boundary line are actually not a part of the solution region of this inequality. Now, how do we finish? This is our boundary line. We shade the right or left side of this boundary line. To find out what side we shade, we pick a test point. I'll choose, say, 2, 1. Check the test point, remember, in the inequality, not the related equation. So let's check the test point here. If y is 1 and x is 2, is this true or false? Is 1 greater than negative 8? The answer is yes. That is a true statement. Then this point should be a part of the solution region, which means where do I shade? I shade then the side of the boundary line where the test point lies. So here I'm shading the solution region of this linear inequality in two variables. Every single ordered pair in this region satisfies that inequality, but not points on this boundary line.